Ordovician period, beginning 485 million years ago, was the second period of the Paleozoic era. It was named by the British geologist Charles Lapsworth in 1879. He took the name from an ancient Celtic tribe, the Ordovese, known for its resistance to Roman domination. This period was a time of great change, affecting plate tectonics, climate, and biological systems. Due to the rapid seafloor spreading, extremely high sea levels resulted in flooding of many continents. This caused an abundance of fossils of marine animals as sediment was deposited. The atmosphere was thought to have several times higher the amount of carbon dioxide than there is present today. This created warmer climates, almost tropical-like. The Ordovician period was also known for having a large increase in many different types of marine animals. The diverse marine invertebrates include graptolites, brachiopods, and trilobites. A typical marine community consisted of these animals, plus algae. Primitive fish started to make an appearance. There was coral and gastropods. Some of the first plants began to appear on land, and there were even some animals. They were pretty similar to today's millipedes. While this time seemed like a growing and wonderful time for the beginning of a new and diverse life on Earth, it was quickly terminated by a mass extinction that was taking place. This extinction is thought to rank second in terms of life affected out of 5. The most known and often talked about extinction event was that at the end of the Cretaceous period, better known as the end of the dinosaurs. However, this event was actually twice as severe as this. It is thought that almost 85% of all species became extinct during the Ordovician extinction event. The extinction may have occurred in several different phases, and there are still many debates on this and as to the exact cause of this event. Some believe that there was an early phase that impacted the brachiopods and trilobites that occurred before the major fall of sea level. This was then followed up by a second phase of extinction that occurred due to the fall of sea levels. Africa and South America were beginning to ice over, so scientists believe that an onset of significant global cooling was occurring, which is represented by the invasion of cool water brachiopod fauna in tropical latitudes. A third phase of extinction may have occurred with the rise of sea level that took place during the Silurian period. Now, as the actual cause of the event, this is much more up in the air. Currently, there are about 4 known reasons that are often discussed and debated amongst scientists. 1 is glaciers. 2, volcanism. 3, a gamma ray burst hypothesis. And 4, metal poisoning. The first cause is often thought to be glaciers. According to Peter Sheehan, a curator of geology at the Milwaukee Public Museum, sea levels dropped very rapidly when glaciers in the south began to expand suddenly. Seth Finnegan, a postdoctoral researcher at the California Institute of Technology, has been conducting a study to support this theory. Finnegan and his researchers were able to estimate the temperature of the tropical seas using a new chemical analysis. There has been evidence that supports the tropics cooled drastically. They also found that ice volumes were extremely high during this time. Their findings are based on a new technique that is used for analyzing the geochemistry of fossils. They used fossils from the late Ordovician period that were found in North America and Canada, which was once considered the tropics. Hard to believe. They use the molecular weight of the carbon and oxygen atoms in carbon dioxide produced by the fossils dissolved in acid to give them clues on the temperatures of this time. Finnegan admits that this is an extremely difficult process to do. So after determining the temperatures, the researchers then look at the oxygen isotopes to estimate the extent of the glaciers. The second potential cause may be volcanism. Some researchers believe that they have discovered a pivotal role that volcanoes may have played in the extinction of the Ordovician period. Matthew Saltzman, a professor at Ohio State University, and his team have discovered that while global cooling ultimately killed 2/3 of the species, or is thought to have killed 2/3 of the species, the other part of the story is actually a giant Atlantic volcano that may have been the root cause. This volcano would have spewed carbon into the atmosphere at the same time the Appalachians were removing it. This put the climate in sort of a stalemate. But then the eruption stopped, which caused the carbon levels to fall below where they had been. This is what kicked off the Ice Age and ultimately became the reason for the extinction of the Ordovician period. A third potential may have been a nearby gamma ray burst. The University of Kansas actually played a huge role, along with the scientists at NASA, at coming up with this hypothesis. Dr. Adrian Malott of the Department of Physics and Astronomy at KU, along with NASA, believe that a cosmic explosion a few thousand light years away may have altered the environment during this time. It has often been suggested by researchers that supernova, explosions of stars, could flood the Earth with deadly radiation if they happen close enough to us. They would have to happen closer than 100 light years away. Supernova are just firecrackers in comparison to gamma ray bursts. The scientists are using an atmospheric model and sort of a what-if scenario. They've calculated that gamma ray radiation could deplete up to half of the atmosphere's protective ozone layer. A recovery from this would take at least 5 years. Once the ozone layer is damaged, ultraviolet radiation from the sun would then kill off land and sea life and disrupt the food chain. They believe that such a harmful radiation is a perfect explanation to this extinction event. Dr. Malott was quoted to say, "We don't know exactly when one came, but we're rather sure it did, and it definitely left its mark. What's most surprising is that a 10-second burst could cause years of damaging ozone." Brian Thomas, a PhD candidate at the University of Kansas, whom Malott advised working with NASA, he worked with NASA on creating detailed computer models that calculate the effects of nearby gamma ray in the atmosphere and then the consequences that it would have on the life. They then calculated the effects of the ultraviolet radiation on life. Surface-dwelling plankton would not have survived this at all, and as most of us know, plankton is the foundation of the marine food chain. Dr. Bruce Lieberman, a paleontologist at the University of Kansas, actually originated the idea. While an ice age does appear to have happened, the gamma ray burst could have been the original cause of the die-out early on, and then this could have triggered the significant drop in surface temperature on the Earth. The final theory for the cause of the second largest mass extinction is actually one of the newer theories. It is believed that toxic metals in the ocean may have played a role. It is thought that there was a change in the ocean chemistry. So when seawater oxygen levels dropped due to an influx of nutrients, the metals that lie on the ocean floor dissolve. The rising exposures to these metals may have caused the plankton to actually develop into monstrosities. There is evidence of these monstrosities through fossils, which you can see have deformations, and they have been found to have 10 times greater heavy metal concentrations than fossils that appear to not have deformations. Similar deformities are seen in marine and freshwater organisms today, which is often a sign of high levels of toxic metals in the water. The presence of heavy metals can severely disrupt the formation of seashells. They can harm fish, birds, humans. So the thought of it harming all these marine animals is a pretty good bet. Scientists, however, can't say exactly what causes the depleted oxygen, though, in the ocean, therefore leaving yet another gap in a potential theory. The Ordovician extinction was a very impactful event in Earth's history. While it could be one of these theories that we discussed, maybe a combination of 1, 2, 3 of them, or a completely different theory altogether, they are all very interesting possibilities to this great event. It appears that many scientists are very curious as to why and how this occurred and are working diligently to find the answers and the evidence to support their theories. Hopefully, one day we receive a definitive answer to the second greatest mass extinction on Earth. Which theory do you think is correct, if any? Think about it.